All right, here we are looking at Wobbly Earth Part 1. We have a little setup here where I'm just going to confirm everything is good to go. We've got our Earth, we have our flashlight, which is representing our sun, and then our setup here, we want it to be about 30 centimeters away. So I'm just readjusting this to make sure it's in the right location. And I just have the Earth flat. So this here is our equator, right? Our line that divides the northern hemisphere and the southern hemisphere. So our first observation is, with this setup, where do I see a majority of the light hitting the Earth? You can scroll back up, take a look at that diagram we made. Is it mostly at the North Pole, South Pole, equator? What location do we see a lot of the sunlight at? Now what we're gonna do here is think about how can we make more sunlight reach certain areas. So as you see in number 3, we want to think about how can we make more sunlight reach the North Pole, and what can we also do to increase the solar intensity, so the directness of the light, or the level of the light. So more solar intensity would mean a brighter or a hotter amount of temperature. So ideas that we're kind of bouncing around in class will have to do with tilt. So what I want: more tilt, less tilt, towards the Earth or towards the sun, away from the sun, to change that sunlight to reach the North Pole. How would I do that? And what would I also need to do for solar intensity to make this sunlight hitting the Earth be stronger? Would I want to move tilt again, or might it have something to do with distance, right? If I'm thinking about trying to get a greater solar intensity. So this is a predict type of question. Predict what change might we make, and kind of go with that. Okay, so you can pause the video at this time and answer those couple questions. Go ahead, hit play when you're ready to work on number 6. For number 6, we're replacing our globe with a clipboard, and I'm just going to change the angle of it a little bit so you can see the clipboard a little bit better. Come this way a little. Okay, so again, we have our sunlight and our clipboard. I want that to be at our same distance, our 30 centimeters. And what we're looking for is, how is that surface area of the light changing? So surface area referring to how much of the clipboard is covered by sunlight. So more surface area would mean a bigger amount of sunlight covering the clipboard. Less surface area would be smaller. Okay, so our degrees we're looking at here are 90, 110, and 130. And you can see it kind of goes off the clipboard a little bit up here. So one more time: 90, 110, and 130. So you have 3 pictures there in your number 6. See if you can find the match. Which one would be the 90-degree picture, the 110, and the 130? So wrapping up with your observations, you just have a few things to finish and think about. Does this amount of sunlight coming from the flashlight change as I'm changing things in my model? So is the amount of sunlight changing ever? And then try to connect which angle, the 90, 110, or 130, which one covers more surface area, and what might that mean for light at the poles?